So let's start with the basics of containers. First, we're going to understand what a container is and what problems it solves. We will also look at a container repository, which is basically a storage for containers. We'll see how a container can actually make the development process much easier and more efficient, and also how they solve some of the problems that we have in the deployment process of applications. So let's dive right in and understand what a container is. A container is a way to package applications with everything they need inside of that package, including the dependencies and all the configuration necessary. And that package is portable, just like any other artifact is. And that package can be easily shared and moved around between a development team or development and operations team. And that portability of containers plus everything packaged in one isolated environment gives it some of the advantages that makes development and deployment process more efficient. And we'll see some of the examples of how that works in later slides. So as I mentioned, containers are portable, so there must be some kind of a storage for those containers so that you can share them and move them around. So containers live in a container repository. This is a special type of storage for containers. Many companies have their own private repositories where they host or where they store all the containers, and this will look something like this, where you can push all of the containers that you have. But there is also a public repository for Docker containers where you can browse and probably find any application container that you want. So let's head over to the browser and see how that looks like. So if I here search for a Docker Hub, which is the name of the public repository for Docker, I will see this official website. So here, if you scroll down, you see that there are more than 100,000 container images of different applications hosted or stored in this Docker repository. So here you see just some of the examples. And for every application, there's this official Docker container or Docker container image. But if you're looking for something else, you can search it here. And I see there's an official image for, let's say, Jenkins. There's also a lot of non-official images or container images that developers or even from Jenkins itself, they actually store it here. So public repository is where you usually get started when you're using or when you're starting to use the containers, where you can find any application image. So now let's see how containers improve the development process by specific examples. How did we develop applications before the containers? Usually, when you have a team of developers working on some application, you would have to install most of the services on your operating system directly, right? For example, you are developing some JavaScript application and you need a PostgreSQL and you need Redis for messaging, and every developer in the team would then have to go and install the binaries of those services and configure them and run them on their local development environment. And depending on which operating system they're using, the installation process will look actually different. Also, another thing with installing services like this is that you have multiple steps of installation. So you have a couple of commands that you have to execute, and the chances of something going wrong and error happening is actually pretty high because of the number of steps required to install each service. And this approach or this process of setting up a new environment can actually be pretty tedious depending on how complex your application is. For example, if you have 10 services that your application is using, then you would have to do that 10 times on each operating system environment. So now let's see how containers solve some of these problems. With containers, you actually do not have to install any of the services directly on your operating system, because the container is its own isolated operating system layer with Linux-based image, as we saw in the previous slides. You have everything packaged in one isolated environment. So you have the PostgreSQL with a specific version packaged with the configuration and the start script inside of one container. So as a developer, you don't have to go and look for the binaries to download on your machine, but rather you just go ahead and check out the container repository to find that specific container and download on your local machine. And the download step is just one Docker command which fetches the container and starts it at the same time. And regardless of which operating system you're on, the Docker command for starting the container will not be different. It will be exactly the same. So if you have 10 applications that your JavaScript application uses and depends on, you would just have to run 10 Docker commands for each container, and that will be it. Which makes the setting up your local development environment actually much easier and much more efficient than the previous version. Also, as we saw in the demonstration before, you can actually have different versions of the same application running on your local environment without having any conflict. So now let's see how containers can improve the deployment process. Before the containers, a traditional deployment process will look like this. Development team will produce artifacts together with a set of instructions of how to actually install and configure those artifacts on the server. So you would have a jar file or something similar for your application, and in addition you would have some kind of a database service or some other service also with a set of instructions of how to configure and set it up on the server. So development team would give those artifacts over to the operations team, and the operations team will handle setting up the environment to deploy those applications. Now, the problem with this kind of approach is that, first of all, you need to configure everything and install everything directly on the operating system, which we saw in the previous example that could actually lead to conflicts with dependency versions and multiple services running on the same host. Another problem that could arise from this kind of process is when there is misunderstanding between the development team and operations, because everything is in a textual guide as instructions. So there could be cases where developers forget to mention some important point about configuration, or maybe when operations team misinterprets some of those instructions. And when that fails, the operations team has to go back to the developers and ask for more details, and this could lead to some back and forth communication until the application is successfully deployed on the server. With containers, this process is actually simplified because now you have the developers and operations working in one team to package the whole configuration, dependencies inside the application, just as we saw previously. And since it's already encapsulated in one single environment, and you don't have to configure any of this directly on the server. So the only thing you need to do is run a Docker command that pulls that container image that you've stored somewhere in the repository and then run it. This is of course a simplified version, but that makes exactly the problem that we saw on the previous slide much more easier. No environmental configuration needed on the server. The only thing, of course, you need to do is you have to install and set up the Docker runtime on the server before you will be able to run containers there. But that's just one-time effort. So as you saw, I used Docker as an example to explain the concepts of containers. However, it's important to note here that Docker is just one of the implementations of containers, one of the most popular ones. Some other popular container technologies are Containerd, CRI-O, etc.